In this video, we're going to look at parabolas and how certain parts of the equation can influence where that vertex is and where the parabola opens up from. In a previous video, we looked at the value of a, the coefficient of the x squared, and how it will influence the width of the parabola and whether the parabola opens up or down. So a little reminder, if a is positive, we generally have the parabola opening up. In fact, we always have the parabola opening up. If a is negative, it's going to open down. The three parabolas here on the right are all opening up, so a is positive in each case. What we have here is a situation showing how the value of a, not just its sign, can influence the width. This red equation in the middle is actually just y equals x squared. The blue graph that is thinner actually has a higher value of a, has a value of 2x squared. As the value of a gets higher, what it does is it stretches the height of the parabola, and that makes it look like it gets narrower. So the width appears to get narrower. The green graph on the outside actually has an a value of 1/4. As your a value goes down from 1 towards 0, it's going to widen the parabola because in essence it's shrinking the height. So the a value involves whether it tells you whether the parabola opens up or down and the width of the parabola. What we're going to look at in this video, though, is how we shift a parabola from side to side or up and down. All right? Through experimentation in Desmos, we saw that adding a constant on the outside shifts the graph vertically by k units up if k is positive and down if k is negative. So having a constant on the outside of the square shifts it up or down. Having a constant on the inside is going to shift it left or right, but it's going to be the opposite way we expect. And this is a key thing to remember. If h is positive, it's actually going to go left in the negative direction. So, and if h is negative, then it goes right in the positive direction. Okay, so it's the opposite direction you would expect. So again, shifts opposite direction. And that's an important thing to keep in mind. So anything on the inside is going to go the opposite direction. Whereas when you add something on the outside of the square, it basically mimics the sign you see. All right, so a couple of examples here. Let's say we have these four equations for the functions f, g, p, and w. Based on the equation, let's think about how the graph has been shifted. Starting with f, notice that the constant is added on the inside here. 3 is added on the inside of the square. So that's a left or right shift. It's a plus 3. So remember, plus 3 would be the opposite direction, so you would shift left in the negative direction. In the function g, the plus 1 is on the outside of the function, so that's an up or down movement. And the sign tells us exactly which direction to move. So because it's plus, we shift up 1 unit. The function p has two constants in with the square. It has a constant on the inside, this minus 5, and then a constant added or subtracted on the outside. Remember, subtraction is just addition of a negative. So what we have here, if we look at them one at a time, is the negative 5. Remember, inside opposite direction, so that's shifting right 5. And then the negative 2 on the outside, that means down 2. So there's two shifts in that graph. W of x has, again, two alterations. We've got a plus 4 that's added up before the square happens and a minus 5 after the square. So an inside and outside movement. Plus 4 on the inside, think opposite direction. Shift left, because left will be in the negative direction. Left 4 units. And then the minus 5 is on the outside. Direct shift, minus means down 5 units. So these are shifting rules for parabolas. You're going to see these again in Math 111. In fact, we will in Math 111 look at this in general for how this works for not just parabolas, but for other types of graphs. Now, we can extend this and look at specific points in the graph of a parabola. In particular, the vertex is a hugely important point in the parabola. The graph of y equals x squared, remember, has a vertex at the origin. So if we think about how the vertex is being shifted just like the rest of the graph, we can actually shift that point and find where the vertex is of any function if it's written in that form of being able to see a constant added on the inside or a constant added on the outside. So if we look at this first function, this is the one we had in the last, all of these are the examples from the last page. We have x plus 3 quantity squared. The 3 is on the inside, so remember that means shift left 3. So if my origin point, 0, 0, got shifted left 3 units, I would be at a negative 3. So it's only the x value that's shifting, so my y value would stay at 0. So there's my vertex, negative 3, 0. My second graph, remember the plus 1 means it's on the outside, so it shifts up. That's only going to be shifting the y value because y is up. So we wouldn't change the x value from the origin. We'd stay at 0, and my y value would be 1. In the next function, we shifted with the -5 right 5, so that means my x value increases by 5, goes to the right 5, and my y value goes down 2, so that would be from 0 down 2 would be -2. So my vertex is 5, -2. And then in my last example here with specific numbers, we have a +4 inside the square, so that means +4 means go the other direction, so -4 from 0, and then the -5 on the outside, shift down 5, so from 0, shifting down 5 would be -5. So we can very easily, with the shifting ideas, actually shift that original vertex, which was at the origin. What we're after here is just a general rule. If you have a quadratic function written in this format where you see a constant inside the square and then a constant added on the outside, this is often referred to as vertex form. I am leaving one thing out, which I'll go over next, but this is in essence vertex form where the a is 1. And when you have this format, the vertex can always be easily seen. That's why it's called vertex form, by thinking about the shift from the origin. Notice instead of putting a +h here, I wrote a -h inside. That's because that's typical of how most books show it, because they want you to remember that the h, the sign you see there, is the opposite of the direction you're going to move. So often they'll show it with a minus to emphasize it. So when we think about it with the minus, then just HK would be the vertex because the sign change has already occurred by writing a minus there. So when you have an equation in vertex form, you know the vertex.